what we're looking at here is a diagram. This is the internet. This is your router, which is the boundary between your internal network, which is here in green, and the internet at large. And so conventionally, you'd have your router, which acts as a boundary between you and the internet. Then you would have inside your internal network, you'd have, for example, a web server, maybe an API server, and then you would have this hatched green line here, which indicates your DMZ, or your demilitarized zone. And then that would be represented by a firewall. And then inside your network, you would have other resources like, for example, your database server. So what this meant was that if someone wanted to attack your database server, for example, which is where the data is stored, so it's obviously the most sensitive point on your network, they would have to be able to get through your router into your internal network, then through your DMZ, and then only then would they be on the right range to start attacking your database server. So that's a multi-step process. So that is a pretty optimal setup security-wise. Along with this setup was the idea that when security updates are released, you would conventionally try to apply them to your servers within a maximum of, say, 3 weeks of release. And that was a commonly accepted wisdom and seemed reasonable on the basis that your database server is protected within these multiple layers of protection. You've got your router, you've got your DMZ, and then ultimately inside your network you've got your database server where the gold is kept. If we compare this with a conventional cloud setup, what you've got here is the internet at large, and then you've got your various servers. So you've got your API server, you've got your database server, and you've got your web server, just as in the previous setup. But each of them is directly connected to the internet and is routable via a non-RFC 1918 address, which just means that anyone on the internet can attempt to connect to them. If someone wants to try and connect to your database server, all they need to do is work out what the IP address of it is. They can route to that over the internet, so they can just type into their browser or whatever means of connection they're using, type in the IP address, and they'll be taken directly to the login form for your database. So as you can see, there are fewer layers of protection in this scenario, and this comes with a number of problems. So the first problem with this is that all you need is one set of credentials, one username, one password, and hopefully a multi-factor authentication token in order to connect to your database server. So you haven't got the external router as a blocker, you haven't got the DMZ as additional firewalls, you've just got your database connected directly to the internet. Anyone can try and connect to it. So if your credentials were leaked for any reason, if they'd been reused on another website, for example, and that website was compromised and attackers were able to gain access to all the usernames and all the passwords, they spray them across the internet, they identify that your database server will accept those credentials, and they can just log on. That wasn't the case with the natted example. So that's one big problem with the having your database server connected directly to the internet. Another issue is that if you stick with the original principle of trying to apply security updates within 3 weeks of release, then your database server is connected directly to the internet. Attackers are able to enumerate that it is a database server, that it's connected to the internet, and if there's an exploit that will allow them remote code execution on the server, then they can just run that exploit and connect directly to the server and start downloading your data. If your servers are based in the cloud and they're directly internet routable, then and you only apply security updates within 3 weeks of release, then that gives your attackers 3 full weeks to be able to identify and exploit your database server. And there's really nothing in place to prevent them from doing that. There are ways that using a cloud configuration you can set up something similar to the natted example. In Azure and in AWS there are protections available that you can enable and configure, but they're not enabled out of the box. So the thing that's of critical importance here is to identify, are your servers exposed to the internet, and if so, are you patching them with a degree of regularity or a degree of speed that means that when a exploit is released against your database operating system version, attackers aren't able to just scan the internet, identify your servers, run the exploit, compromise them, and take the data, which is very commonly the case. So how do you make sure that you've applied all the security updates that could possibly have an impact on your operating system? One way is through having a very detailed asset register and knowing when updates are released to absolutely every bit of software running on your servers. But a much easier and more cost-effective way of identifying any flaws that might be exploitable is by doing external vulnerability scanning. For the price of £23 you can run 3 vulnerability scans, scan the external interfaces for all of your cloud-based servers, identify if any software patches are outstanding that may have been missed when you updated the operating systems, and as a result you can minimize your risk and keep the bad guys out. So probably vulnerability scanning is the easiest way of actually doing this in a practical manner, because it's very difficult to know what dependencies are running on your servers. Operating systems and software packages are increasingly complex, and it might be that your servers or your software are using dependencies that you're not even aware of. Examples of this might be OpenSSL or different forms of JavaScript dependencies, which often get missed in the updating process. Sometimes their automatic updates won't even include JavaScript updates, and you need to do these manually. Without vulnerability scanning, you may not even be aware that those dependencies are in use, and as a result, you may not know that you need to update them. So, yes, definitely get in touch, and I'll be happy to take you through a demo of how you can run scans yourself, or we can run the scans for you if you'd like a done-for-you service, and make sure your data is safe and keep the hackers out. Thanks very much for watching, and I look forward to speaking to you soon. Bye.